All right, here we are. Welcome to our second lab. Hopefully you survived the first one. And this is Pivot Lab Intro to Periodic Trends. Okay, and this one's going to have a lot to do with the periodic table. So let's get on with it. See what we got here. All right, the first simulation is pretty straightforward. Um, it's got a little um, our brain is a little dead, but that's okay. Make sure you click on the word mass number here. You have a periodic table up here. Notice if you have the first two rows or periods right here. If you click on hydrogen, it will be red up there. If you click on helium, that spot goes, and so forth for any of these first basically 10 elements, okay? And it will change over here and tell you what the mass number is and all of that sort of thing, okay? Um, so we'll ask you a little questions about that, about how that changes as you go across the period. All right. And it's also going to ask you to talk about the radius. The radius is the distance from the center to the edge, to the outermost electrons, so to speak. And as you move them, you can see how it changes. There's not a specific measurement or anything, but just kind of see that general trend of how do they change. Okay. All right. And that should be pretty straightforward. Now, they're going to use a lot of graphs in this section. Okay. I would recommend having your copy, a paper copy of your periodic table handy and available, just to save yourself looking up. Sometimes it does have under the hint button or something, it will have have a periodic table, but sometimes that scoot your question out of the way. So whichever works best for you. Okay. I like having just a paper copy with me so I can write on it, mark things and things like that. Um, Also, I should say this is called the side-by-side view where you have the chart over here and the questions over here. If it's easier, you can do this inline question view, which means the chart or whatever will take up the whole page and then the questions will be underneath it. Uh, there's advantages both directions, but whatever you prefer. I'm going to stick with side-by-side. That way I can keep the chart here as I slide the questions by and try to answer them. All right. And so if you move your cursor over the chart or the graph, it will show you the atomic number. Okay, it will not give you the name. You can look that up on your graph and see where it is. And as it moves, this little number over here, whoops, in the like 37 on this one, would tell you that this is element 37. And then you can look on your chart and say, oh, element 37, that would be, no, I don't have all of them memorized in my head. There was a time when I was close, but anyhow, you would say that's rubidium. Okay, and so you can do that. Okay, so you will have to kind of look that up from time to time. So basically, it's going to be talking about how do the atomic masses changes as you go in different parts of the graph. Okay, and then it's going to give you some examples of elements, and based on the rules you've learned, you should be able to say where that is going to happen. Okay, atomic radius. Once again, this is how far from the center of the atom to the edge. Okay, now they're going to give you once again a graph with numbers. Same thing. The number up in the upper left-hand corner there, like 39 right there. That will give you the element number, and then it gives you actual value for the number, the actual radius of that particular element. Okay, and so once again, they want to see what is the trend with periods and groups. Periods, remember, going across, groups are going down. How does that change as you do that? And why would that change as you do that? Okay. All right. I'm going to talk to you a little bit about charges. Okay. This just gives you an example of an atom to start with 3 protons, and you have an electron this distance from it. All right. Now, compared to that, they're going to say, okay, now this, for example, has more protons and the same distance. So what would the arrows look like? Okay. Are they going to be attracted toward each other, or are they going to be attracted away from each other? And is it going to be a small force or a larger force compared to this first one up here? Okay. And so that's kind of what you're looking at for each of those. That one's a little confusing, but you have 3 submissions. So you should be able to get there. And then over here, you're going to give an example and describe what's happening, for example, between these 2 electrons, and put that explanation off to the side. All right. So that's kind of how that one works. Once again, how does it change as you go across, and trying to see what those trends are. And those trends, remember, those repeating patterns See this repeating pattern. You got a line here, a line here, a line here, a line here, and a line here. And they have kind of the same repeating pattern, and that's why they're called periods, or the rows are called periods, because a period is a repeating pattern. So we'll do some more on that, on the atomic radius. All right. Now, the next two sections, one's ionization energy. I don't talk about that one as much because it's very similar to the next one, which is electronegativity. But just to go over it real quickly, ionization is how much energy does it take to take away or remove an electron. Okay. Electronegativity is how tightly does the atom hold on to the electron. Okay. So they are going to be kind of similar. If it doesn't take much, if they don't hold on to it very much, it's not going to take much energy to take it away, and vice versa. If it has a lot of hanging onto it really tight, then it's going to be hard to pull it away. So it's going to take more energy to pull it away. So generally, if there's a high electronegativity, they're really hanging on to them, you're going to have a high ionization. So they're very similar. You'll notice trends as they go through them, okay, to each other. But there are two separate sections, so that means more questions you have to answer, sorry. But that would be ionization and electronegativity. And then finally, they're going to look at some patterns in the number of valence electrons, okay? Remember, the valence electrons are the number of electrons on the outside layer. Remember, the inside layers, not much happens there. They're pretty well part of the atom. They're too close to the nucleus to be pulled away. But on that outside layer, they can be pulled away, all right? Or they could add them. And that's where all the things that happen that give the atoms their properties, okay, that make them the way they are, make them react the way they do, make them have the charge they have, or if they share electrons or whatever. All of that is determined by those electrons on the outside layer. And the outside layer, while it's the outside layer, can only have 8 electrons, okay? After another layer becomes the outside layer, then they may fill up some more on those inner layers, but not, but the outside layer will never have more than 8 electrons in it. Okay, all right, and then there's a few things here at the end. They give you a periodic table, and notice on this one there's an arrow pointing to the right. So as you go this direction, what happens to each of these? Do they atomic mass? Does it increase, decrease, or stay the same as you go across the periodic table? Okay, and same thing for each of these other variables. Okay, then they want to know over here, going down, as you go down the group, what happens to the atomic mass? What happens to the atomic radius? Does it get bigger or smaller, or stay the same? Once again, same thing. All right. And then one more time, just to make sure you got it really good, they're going to have a drop-down menu, but basically it's going to tell you as you go across the period or down the group. All right. As I more think about that one, maybe I should just take that one off, because basically by the time we've done the other one, okay? So if you get to this part of the lab and you don't see that one, that may be because I decided just to take it off, all right? But I'll tell you about it just in case I don't take it off, all right? Other than that, I think that pretty well gets us to the end. If you have any questions, you know my email address, so enjoy and have a good time trending on the periodic table.